In this video, we'll look at small multiples or trellis charts. A small multiple, sometimes called trellis chart, lattice chart, grid chart, or panel chart, is a series of similar graphs or charts using the same scale and axis, allowing them to be easily compared. It uses multiple views to show different partitions of a dataset. This term was popularized by Edward Tufte. Let us take this big chart for example. You may have multiple values you want to compare, and while it may seem to be a good idea to put all these values in one big chart, comparing the values of each individual line can become so confusing and unwieldy. This is when we can consider creating small multiples. A small multiple is taking that one big chart and creating smaller versions of it so that we can compare them side by side. When we create small multiples, we sacrifice having bigger graphs. We don't see as many details, but we are able to compare multiple slices of the same graph in a smaller format side by side. You see them all at one glance. And even though we don't get the same details, we get to compare the general patterns side by side. In this video, we will look at how to create these small multiples in Tableau. I'll see you in a bit. Creating a small multiple in Tableau can be straightforward, or it can be a little bit complicated. If you already have the dimensions you want to use for your partitions, this can be straightforward. So for example, in this chart, if we simply wanted to partition this by date, we can take that date, put that in either row or column, and it will create smaller versions of the same chart. If we wanted to further slice this by category, we can take that category and then put that in the other shelf. Again, this is an example of a very simple small multiple. But what if we wanted to create a small multiple based on only a single dimension value? For example, let's create a brand new sheet, and in here, let's create a time series graph. Right-click, drag order date, continuous month, click on OK. Let's take sales onto rows. And for this demonstration, I'm going to put subcategory on color. So instead of slicing and dicing this by other dimensions, maybe we simply wanted to see all subcategories in one panel, in one grid. We have some challenges. For us to create a small multiple, we need some discrete dimensions that allow us to create the grid. So we are going to have to create calculated fields that allow us to create these grids. This is the small multiple we are going to create in this demo. This allows us to compare subcategory sales side by side in one view. This chart might seem so colorful, but I'm going to explain later on why we're using color and how it can help us validate our data. Your final small multiple or trellis chart does not need to be this colorful. I just want to note that there are a lot of strategies to create these small multiples in Tableau. I'm going to show you one, but I'm pretty sure you're going to find other strategies from a lot of fantastic resources out there. Let's go over the high-level steps first on how we can create this small multiple. There's two general big steps. The first one is we need to be able to create the grid or the matrix. The second step is we want to be able to add labels so that we know exactly what we're looking at. Each of the bigger steps have smaller sub-steps though. To create the matrix or the grid, we have to create a few calculated fields. First one is an index. The second one is columns, and we are going to derive this from the index calculated field. Third one is rows. And fourth one, we are going to need a new date. And I'm going to demonstrate later on why we need to create a new date. And once we create a new date, we simply need to use it. There's also a few steps we need to create and display the label. First, we need to calculate the sales for each panel. We also need to find out the maximum sales in any one panel. Next, we need to find a midpoint or a halfway mark where we can put these labels. And lastly, once we have all of these pieces, we can display our label. Let's now jump back to Tableau and create the small multiple step by step. Let's create our first calculated field. So on the drop-down, create calculated field, and let's call this index. And this simply uses the table calculation function index. So what is index? If you place your cursor in the function name, and if you expand on this calculated field window, you're going to see a description of this function. It says here it returns the index of the current row in the partition. The index function, again, this is a table calculation function. It simply returns a sequential number based on the direction and the scope that you specify for that table calculation. Let's click on OK first, and let's just demonstrate what index is or what it does, because I think it's important for us to understand before we move forward. Let's also just change this index into a discrete field. Let's create a new sheet. Let's place subcategory onto columns. And let's simply display index in text. So we can see in here that the index function simply gives us a sequential number. It gives us a number from 1 to n. So it starts from 1 all the way to the maximum number of distinct values we have for subcategory. In our small multiple, we may want to simply display, let's say, 5 columns. So the subcategories with the index 6 to 10, we may decide to put that and stack that on top of the previous values, which means that for chairs, instead of column number 6, we want this to be column number 1 again. And copiers, we want this to be column number 2, number 3, number 4, number 5. So how can we do that? So our second calculated field, where we can calculate the column number, can be based on the index. We just need to make sure that the calculation gives us these values instead of the original index number. Let's first create a parameter that will hold the number of columns we want to use in our small multiple. Let's call this parameter number of columns. This is going to be an integer. And let's say we start with 5. The reason we are creating a parameter is because we don't want to hard code this in any of the next calculations we're creating. If we hard code this value, it's going to make it harder for us to maintain and change this in the future should we change our minds and make this 10 columns, for example. So let's click on OK. And now let's create our second calculated field. So on the drop down, create calculated field, and let's call this one columns. We are going to use our index calculated field in here, and we are going to use the operator called modulo. And the modulo operator is a percent sign. And in here, we're going to use the number of columns. Let me click on apply first and display this, and let's talk about this a little bit more. Let's also just convert columns into a discrete field. So right click, convert to discrete. So let's take a look at what's happening. The modulo operator gets the remainder after a division. So in this case, we have the value number 1, modulo, and then the number of columns we have set right now is 5. So 1 modulo 5, if we divide 1 by 5, the remainder is 1. So this is the number that we're seeing. For the next set of values, let's start with 6. 6 modulo 5, 6 divided by 5, the remainder is also 1. So we're very close to what we need to accomplish. We're seeing that the 6th value is now reassigned to column number 1. 7th value reassigned to column number 2. We do have one final change that we need to apply, because in here we can see that value number 5 is actually receiving a column 0. And it's because 5 modulo 5, if we divide 5 by 5, there is no remainder. Therefore, the modulo is 0. The remainder is 0. So we simply need to reassign 0 with the number of columns. So let's add that. So I will use an if-else statement in this case. So if this value is 0, then we simply want to display the number of columns. Otherwise, we want the original value and then end. There are simpler ways to do this, but I'm going to use the if-else statement because it makes it easier to follow the logic, especially when you're just trying to understand what's happening under the hood. So let's click on apply. And in here, we can now see that we have successfully created our columns. So the second set of values have been reassigned to columns 1 all the way to 5. So now we're ready to create rows. What we want to do is we want to leave the first 5 values in the first row, but the second 5 values, we want to shift this over so it goes to the next row. The next 5 values onto the third row. So how do we create this calculated field? So let's create a new calculated field. Let's call this rows. We're still going to base this off of the index calculated field. Let's drag index over and let's divide this by the number of columns. Let's click on apply first and display the values. Convert rows to discrete and display it. So what we want to achieve is we want to make sure that the first 5 records have exactly the same value. And the next 5 records will also have the exact same value. So if we take a look at these values, we have a couple options. We can either round the values up so that all of these will get a value of 1, all of these will get a value of 2. Your other option is to round the values down. So all of these values will get a value of 0, and the next 5 records will get a value of 1. There is a function in Tableau called ceiling that will help us round the values up. The problem is the ceiling function cannot be applied to table calculations. So we need to find a different way to either round the values up or down. So what we can do is we can force the values to be all rounded down. So in here we can subtract 1 from our index. Let's click on apply again, and we can see that the first 5 records can now be rounded down to 0. So what we can do is we can convert the data type of these values to an integer value, which means values of 0 to 0.8 will be evaluated to 0. So to convert the data type, we simply need to add int to make it an integer. And once we click on apply, this allows us now to have a single row number for the first 5 records and another value for the next 5 records. So these will be in row 0, and the next one will be row number 1. And it's up to you if you want to add 1 more, if you want to start the row numbers to 1. Let's go back to our chart and create our initial small multiples. Let's add columns to columns and rows to rows. Because these are table calculation functions, we need to make sure we specify the direction and the scope. And in this case, for now, we're simply going to make sure that we're computing. So we're computing along subcategory, and same thing for the rows. And this is why I wanted to use color. Normally, we don't want to use this many colors. Colors are used for highlighting or emphasizing something. However, for this particular exercise, color is very helpful in identifying if we have the correct value. If we simply had 1 color for all these lines, or if we used a bar instead, it's very easy to miss the fact that actually we have some wrong information in here. Let us take a look at row 1, column 1. Notice this chart? This chart actually has 3 different colors, which means this one chart is not representing just a single subcategory. There's 2 other subcategories in here, that small dot over there and this small dot over here. Somehow they're in this same chart. So we need to fix this first. I hope you're enjoying this video so far. If you haven't subscribed yet, please consider subscribing. I publish weekly tutorials on this channel. So let's try to understand, why is this even happening? So I'm just going to duplicate this chart first. So right click, duplicate. Let's just leave this row and column. Keep only. Let's also just leave these subcategories. And now let's take away the rows and columns and take away sales. So what we need to understand in this scenario is that the index table calculation function simply gives us a sequential number, regardless of what values are there. And in this case, some subcategories may not have sales for specific months. Therefore, another subcategory value may be given the next sequential number. If we have missing values, this really throws off the index function. So one way we can fix this is by creating another calculated field for date that will be populated regardless of whether that subcategory had sales in that month or not. So let's create a new calculated field. Let's call this new order date. We are going to base this on our existing continuous date field, so we can just drag this over. We're also just going to cast this again to a date. So if there's any time component, we're going to remove that. And let's click on OK. Let's add the new order date in detail. So we're going to right-click, drag, and add the individual values. So in your drop field window, we are going to use the discrete date. We're not going to use any of the aggregated dates. We're also going to replace the continuous date we have on columns. So let's right-click, drag our new order date, put this on top of the existing pill. And because we want to visualize this as a continuous time series graph, this time around, we're going to use the continuous date for display. There's a few more things we need to do. Since this pill is actually each individual order date from our data source, we still want this aggregated somehow. So we're going to encapsulate this with the adder function, or the attr. So if we have 5 orders in one day, we're getting just one value instead of 5 different values. So we can use an ad hoc calculation in this case. Let's double click on this new order date, and we're going to place attr around this field name. We're going to convert this to continuous because, again, we want this continuous time series graph. But it doesn't feel like we've solved our problem yet. But it's because, remember, for table calculation functions, we need to specify the dimensions that we are considering in this calculation. And in this case, we have a brand new field that we want to consider in our table calculation function. So let's click on columns, edit table calculation. We are going to add the new order date in our specific dimensions so that it's considered in that calculation. And each calculation is at the level of, or at the group of, subcategory. We're going to do the same thing for rows. So on the drop down, edit table calculation, we're going to add the new order date and at the level of subcategory. So now, even just by visually looking at this, we know that we have the correct results. There's only a single set of values from the same subcategory that's being displayed in this small chart. Now let's work on the labels. We're going to create 2 calculated fields. One is for the total sales for that individual subcategory. So in here, let's create a calculated field. Let's call this subcategory sales. And we are going to use a table calculation function called window sum. And when we place this on our canvas later on, this window sum, we need to make sure that the scope is actually just at the subcategory level. It's going to calculate each one of these points and it's going to add up based on this one window or this one group. The second calculation we're going to create is really just for aesthetics. When we place our labels later on, we want to make sure we place our labels in a consistent place and that it doesn't overlap any of our other marks. And for us to do this, we need to know what the highest mark is. So in this case, we can see that the highest sales for all of these is actually for this subcategory. So we want to find this maximum value, and this will allow us to approximate where we're going to place our label. So for this label, we're going to use a fixed LOD. Create a new calculated field. Let's call this max sales. And this is going to use a nested level of detail expression, or a nested LOD. So let's start with the innermost level first. We're going to use fixed, and based on each subcategory and new order date, we want to figure out the sales first. So this will be sum of sales. Now what this does is it figures out each of these dots, each of the values. But out of all of those, we need to find the highest peak. So we can pass this to another level of detail expression, and this time around, we're going to use the table scoped fixed LOD. We're simply going to put a curly brace and the aggregate function max. And we pass our previous LOD into this max function. Let me just quickly reorder this so we can see what's happening. So what we're saying in here is we want to find all individual sales for each month, because remember, our new order date is only at the monthly level. We want to find all of these sales but only retain the maximum value. So let's click on OK. Now, in terms of placement, there are a lot of strategies to do this, and the way I'm going to show you may not work for some cases. But right now, the range of values we have are pretty even, so I can simply find the number of points we have and get the midpoint, the halfway mark in between the first point and the last point. So let's create a calculated field. Let's call this halfway mark. And what we're saying is if the index is equal to half of the points, there is another table calculation function called size that allows us to get this divided by 2. And we're just going to convert this to the integer equivalent. So if the index is at the halfway mark, then we want to display 1 mark, and that's going to be our maximum sales, and end. Notice that at this point, we are getting an error saying cannot mix aggregate and non-aggregate comparisons. And the reason for that is even though we know in the expression we're doing aggregation, the fixed level of detail expression returns a scalar value, and we cannot mix and match table calculations and aggregates with non-aggregated values. So we can simply enclose max sales with one other aggregation function. Could be the minimum, the maximum, the sum, the average. It will not make a difference. It will give the same result back to us. So let's enclose this with a sum and click on OK. So let's now put everything together. Let's take our halfway mark, put that on rows. Now for the halfway mark, we want this to be only based on the new order date. So on the drop down, compute using, and this is going to be a long new order date. And we can see that there's a dot right there at the midpoint. We can also now display subcategory as the label. So we can copy subcategory over to label. And now we can also place our subcategory sales onto label. This is still a table calculation, so we still need to specify the scope and direction. So on the drop down, edit table calculation. Let's move subcategory to the top. Let's select both subcategory and new order date, and we're going to restart the totals for every subcategory. So now we simply just need to adjust our formatting and polish our view. So we can adjust the size of this dot, make that really small so it's not visible. We can change the color so it is fully transparent. If you want, we can change the label so it matches the mark color and maybe adjust the font style. And then we can make this into a dual axis chart now. So click on the drop down on the halfway mark pill, make this a dual axis chart. Take away the extra measure names that has been introduced in both marks cards. So take this out, and in the sum of sales, take out measure names as well. Since we have a dual axis chart, we want to make sure we synchronize. And some additional adjustments that we may need to do is we may need to add additional padding just to make sure that the labels actually don't overlap. So in this case, a common strategy is to go back to that max sales and just add some padding. So for example, we may just want to multiply this by 1.2 or 1.5 or whatever that factor is. So once we click on apply, you can see that the labels will go up. Maybe let's make this a 1.5. There we go. Okay. Let's just do some final touch-ups. And this is it for our tutorial. I know this may seem like a long tutorial, but I wanted to make sure that we go through the steps thoroughly and that we explain and understand why we need to do these calculations or why we need to add extra fields. Hopefully there's some pieces of useful tips that you've picked up that you can use in other projects in Tableau. Once again, I hope you've enjoyed it. I hope you found it useful, and I will see you again next time. Thank you so much for watching.